So what we have in front of us is an Ethernet hub that's been constructed here at the Red Deer College for a demonstration on Ethernet. If we look here, we've got 1, 2, 3 of these breakouts. It's a breakout. It breaks out the RJ45 connector of our Cat5 cable. So you can see here we have this computer has a Cat5 cable, 4-foot Cat5 cable going into this breakout, and then the terminals are broken out 1 through 8. We are using Ethernet 10BASE-T and half duplex. So that means it's all 3 of these computers are sharing the same channel to communicate on. Pins 1 and 2 here are used to transmit a voltage signal out, and pins 3 and 6 are used to receive messages in. So all these breadboards here, like you can see a whole bunch of diodes constructed, is used to connect basically all the transmit and receive channels in parallel, so they're all on one channel for all 3 computers. We have a breakout for each computer. If we come over here, here's the wiring diagram that was used to construct this Ethernet hub, and you can see here's all of the diodes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 24 diodes in that circuit out there, and then here's our 3 ports. You can see here the A1, the A represents pin 1 on port A. B3 would be pin 3 on port B. And like I said over there, pins 1 and 2 are used for transmit, and pins 3 and 6, so we have 6 over here, 3 over here, are for receiving information. What you may not, what I did not say is 1 and 3 on all of these. You can see all these are 1 and 3 over here, and all of these are 6s and 2s. The 6s and 2s are positive in polarity, and the 1s and 3s are negative in polarity.
Just wanted to make a quick correction. It's actually the 1s and 3s that are positive, and the 2s and 6s that are negative.
So basically what this ends up doing is connecting everything in parallel, so we have one channel. So what this does now, if we were to now look at these 2 computers over here, I have a hyperterminal session running. If we look at this computer right here, what I can do is I can push a key over here on this computer beside it, and we should see on the screen there, I'm pushing F, you can see the messages being sent over to this computer. Now if we go and look at the back of our computers over here, on our Ethernet ports, you can see down here we have a green and an amber light flashing where our blue cable goes in. When I push that same key on our computer over here, you can see that amber light starts to blink faster. I let go and it slows down. Push the key, it blinks faster. And what you would notice on all 3 of these computers, the amber light is blinking. When I let go, it slows down. When I push the key, it speeds up on all 3 of these. The reason being that amber light indicates that data is being transmitted over the network. All 3 of those computers are receiving the message. And that's what an Ethernet hub does. It takes the information that's being transmitted by one computer and forwards it on to all the other computers in the network. And the way that we avoid collisions with Ethernet is it uses carrier sense multiple access with collision detection. That's the media access method it uses. That's what I wanted to show, that Ethernet will still function in half duplex, because nowadays Ethernet is used only in full duplex. But it still will function half duplex. That was kind of where it began, and that's why carrier sense multiple access, that media access method, exists. So just to prove that all computers are receiving that same signal, when I pushed the F key or the H key or the J key, you can see here I've pushed multiple different keys on our computer. When I pushed that key on the center computer, I wanted to just demonstrate that it actually is going to this computer, and it actually is going to the Ethernet port on this computer. We know, we've already confirmed by when we push the key on one computer, the message goes, the character goes to the other. What I'm going to use to demonstrate this over here is a program called Wireshark. So Wireshark allows you to monitor the network and look at all the data that's being sent over it. So the hyperterminal session is set up between these two computers. There's no hyperterminal session set up on this computer. All that this Wireshark program is going to do is going to monitor the channel that all three computers are connected to on this Ethernet hub. So what I'm going to do is I'm going to go on Wireshark up here and click capture and start a capture. And just may have to wait here. Now I'm going to push the F key on this middle computer, and we should see here, you can see all these messages coming through. I'm just holding it down, all these telnet messages. Telnet is the protocol that hyperterminal uses. So I'm going to release the key, and now I'm going to just stop the capture, and we're going to go in and look at this information that we captured with our Ethernet hub. So let's just have a look here. It's got source and destination, telnet. If we select one of these frames here, and what we're concerned with looking at right now, we're not going to look at the internet protocol stuff, the transmission control protocol. That's for a later date. But what you can see here is it tells us how many bytes were on the wire. It's the total amount of bits. We can look here at the Ethernet frame. We can drill down in here, and this here is what I wanted to kind of point out, is it shows the destination and source and their associated MAC address right here. So you can see these are both Dell computers, so the starting of their MAC address is the same, and then the last bit changes because no MAC address will ever be the same. So this here shows the Ethernet portion of the frame. If we select this, down here it shows all the source associated hexadecimal values that are associated with the Ethernet frame. And then if we have a look here in the telnet, that was the protocol used by hyperterminal to send our message. You can see down here, this is all that is used out of all of these ones and zeros or hexadecimal values. If you were to convert each one of these hexadecimal values to binary, you'd have the ones and zeros that are actually sent over the wire. This is all that made up our message. 2 6s here in hexadecimal, which equals F, the key F that we pushed. And you can see that's all nicely highlighted for us. If we drill down here, it shows you the data F. So that shows you that it took 480 bits to actually just send the letter F, and this is all that was actually representative of that data. Now, what I wanted to also show, we've proven that this computer can see the information because they're all connected in half duplex. They're all sharing the same channel, so he can view the information. I wanted to bring you over to the oscilloscope here. I've taken a screenshot of the preamble of our Ethernet frame. I've got the oscilloscope connected here across our receive terminals for this computer that has Wireshark on it right now. And I've just freezed the frame when we were sending a value. You can see that I've got the time scale here at 100 nanoseconds per division. If you were to take that and divide it into 1, it would give you a value of 10 million, which is the number of bits that are being sent with 10BASE-T Ethernet. That's what we're using right now.